All right, let's take a look at number 10, which gives us the derivative of some function, and it's asking us what's happening at the point x equals -1. So to find out if f is increasing, what we can do is just plug in the x value of -1 into the equation. And when I plug in -1, I get out -1 squared is 1, 1 plus 1 is 2, 2 to the -1 is 1/2, 1/2 minus 1 is -1/2. Because the derivative is negative, f is decreasing, so 1 is not true. So I can't be A, can't be C, can't be E. So now I only have two choices. All right, here's the thing, is that the function must be continuous because the derivative existed at -1, so 3 must be true. So I'm assuming that the answer is D, but let's go ahead and check the concavity. I'm assuming the second derivative will be positive, but I want to take the derivative on my calculator because, frankly, I don't know how to differentiate that by hand with an x in the base and an x in the exponent. So let's do x squared plus 1 all raised to the x, and then minus 1, and let's take the derivative of it. So grab it into the line, comma x, and I'm going to go, well, let's see what it looks like. That is one crazy derivative, but what I really need to do is do a such that x equals -1 because I want to know the value of the derivative at 1. And let's just green diamond it to make sure, and we get a positive number, so f is in fact concave up, and our answer is D. All right, number 11, the slope of a curve is given by this dy dx. So what's going on at x equals 2? So I could graph this guy, and I think I will because I'm trying to teach the calculator skills here. So if I graph this, I'm going to have x minus 2 all squared, oops, forgot to close my parentheses, and then times x minus 3. Put the multiplication symbol in just in case the calculator wants it. And there's my derivative function. And I have no idea what window to look at, so I'll just do a standard zoom 6. The question is what's happening at x equals 2. So I'm actually going to zoom in now that I see what it looks like, and I'm going to zoom in. The x center I want is at x equals 2. So let's keep on scrolling over to close to 2, good enough. And I'll get a good view. Okay, so clearly we have a horizontal tangent line. If the derivative equals 0, there is a horizontal tangent line at x equals 2. Now, there is also a point of inflection at x equals 2 because there's a local max here. So I will get a point of inflection out of that. What I don't get is a local maximum because I do not cross the x-axis from positive to negative. The derivative, f prime, or dy dx, would have to cross the x-axis from positive to negative at 2 for there to be a local max. So the answer is going to be 1 and 3 only, which is D.